Okay, in today's video, we're going to be talking about the area of a triangle. However, we're going to be using a different formula than what we normally use. We know, pen here, we know that the formula for the area of a triangle is that area is equal to 1/2 times base times height. And this is from geometry to where B is again, the base of the triangle and H would be the height. However, if we look at this triangle, we know that the sine of C, we've got a right triangle. Let me scroll back. We have a right triangle right here. And if angle C is right here, that sine is opposite over hypotenuse. So we know that the sine of C would be H over A. So therefore, if we solve that for H, we know that H would equal to A times the sine of C, if we were to move it over. And if we were to substitute this into the formula for H, if we were to take out the H and rearrange some letters, we would get that the area of this triangle is 1/2 times A times B times the sine of C. And this is a new area formula that we can use anytime we're dealing with a triangle and we have angles. We use it when we have a side angle side type scenario, to where if you've got, again, a triangle like this right here, here's angles A, B, and C, and let's say that you've got two side lengths and you have the included angle. Let's say that's like a 30-degree angle. Again, you have two sides and the included angle. You can now use this formula to find the area of a triangle. As with this, the area of a triangle, and if this is angle A, angle B, and angle C, and this will be the last time we label this, which, by the way, this is angle A, and this A stands for area. Don't get those two A's mixed up. But the area of a triangle is equal to 1/2 times B times C times the sine of A. You can actually use, I rearranged some letters here. So this is just one of the three versions of the area formula. You have 1/2 times B times C times the sine of A, or you have 1/2 times A times C times the sine of B. So any of those would work. So this is just rearranging of the letters. This is still the same formula. So you have 1/2 times B would be 12, C would be 15, and the sine of 110 degrees. And then you can just type that straight into your calculator. Or if you just want to clean it up before you do type it in, what I like to do is half of 12. Since 12 is an even number, I can do half of 12 is 6. 6 times 15 is 90 times the sine of 110. If you'd like to clean it up, just in case maybe it's an ACT type problem. Or again, we could have just typed this whole thing in and we find out that the area of this triangle is about 84.6 centimeters square. Remember that area is in square units. The next one, again, you need a side angle side, which is right here. So you're going to do the area is equal to 1/2 times the two sides. So 1/2 times 6 times 8 times the sine of 72. And it's just that simple. You can type the whole thing into the calculator, or you can simplify. Half of 6 is 3. 3 times 8 is 24. Sine 72 would be the simplified version. And then 24 sine of 72 is equal to 22.8 square meters. Here's your angle on the next one. So there's your side angle inside. So again, 1/2 times, it doesn't matter which one you put first, 24 times 23.5 times the sine of 25. And again, from here on out, I'm just going to type that straight in, and that's going to be about 119.2 square inches. Let's see, the next one, here's my two sides, but I need the angle in between. I have these two angles, which I know the three angles have to add up to 180. Those add up to 124, so that leaves me with a 56-degree angle. So you have the area is equal to 1/2 times 34 times 49.2 times the sine of 56. Typing that into our calculator tells me that this area is about 693.4, and that would be in square feet. Next one, same thing. Here's my two sides. I don't have the included angle, but I can find it by adding these two. That'd be 55, which leaves me with 125. So the area of this triangle would be 1/2 times 14 times 17 times the sine of 125 degrees, which is about 97.5 square meters. Now the next part, we're going to have to actually use our law of sines and cosines, because notice that we don't have the angle in between. Here's our two sides, but we don't have the included angle, and I don't have this other angle. So we're going to have to somehow use law of sines or law of cosines to find this angle here. I do know that since I have an angle in the side across from it, that I can do the sine of 93 over 12, and I can actually use the law of sines here to find missing angles or missing sides, possibly. Let me erase that. The only side length I have is this 7, and it's across from this angle. So I'm going to have to let that be my x. So I'm going to have to do the sine of x over 7. That gives me, move the 7 over, 7 times the sine of 93 divided by 12. Type this in, and again, all this is review. Type that in to move sine over. Once we get that typed in, we will have to do the inverse sine, and I'm going to go straight to the answer. That missing angle, which I labeled as x, is going to be somewhere around 35.6 degrees. Reminder, when you're using law of sines, you might have multiple answers. The other angle would be 144.4. However, if you look at the 93, this cannot be 144.4. So therefore, we only have the one answer. So therefore, there's a possibility on these, if you were to have two different answers, you might have two different areas possible for a triangle. So we got to be careful with that. However, if we look back to our original problem, let me erase some of this. Looking back to our original problem, that's not actually the angle I needed. This was the angle I just found right here to be 35.6 degrees. But to find the area, I need two sides and the included angle. So this is the one I need. So if my angle up here is 35.6, my other angle was 93, add those together, I get 128.6, which leaves me with 51.4 degrees for this one. So now it's pretty easy. We just go back to our area formula. The area is equal to 1/2 times 7 times 12 times the sine of 51.4. And here, if you want this more exact, you might want to put a few extra decimals, because 35.6 was a rounded answer. But I get an area for this problem of somewhere around 32.8 square feet. Next problem. Again, I need side, angle, side. I have one side and an angle. I've got to find a missing side. It really doesn't matter. I could actually find either one. If I had this side up here, I could use the 20, the 28 degrees in it. Or if I had this side down here, I would use 20 and 114 in that. Should give me the same answer either way I work it. So let's see if we can use law of sines here, and we should be able to, because I have 20 here, and I do know the measure of this angle. 28 and 114 is 142, which leaves me with a 38-degree angle. So I can say that the sine of 38 over 20 is equal to, and again, it doesn't matter where you go from here. We can do the sine of 28. We'll just do this one over x. We solve this proportion by multiplying 20 times sine of 28. We divide the answer by the sine of 38. And we get that my missing side, which, by the way, one more time, is this side down here that I'm looking for, is somewhere around 15.3, and that's in inches. So therefore, my area would be 1/2 times 20 times 15.3. And again, the more decimals, the more exact that would be, times the sine of 114. Let's see, 1/2 times 20 times 15.3 times the sine of 114, which is going to be somewhere around 139.8 square inches. Next problem. You've got two angles. I like to go ahead and, even if I don't need it, I know that third angle, that adds up to 144, so that has a 36-degree angle here. This is a law of sines problem, so I have the sine of 62 over 35 is equal to, and again, it doesn't matter which of the two sides that I find. We'll do the sine of 36, I guess, over x. And if you're letting 36 be my angle, this would be my x. And then this will be my side angle side that I used to find the area. I multiply 35 times sine of 36, divide that answer by the sine of 62, and I get that my missing side is somewhere around 23.3 miles. And that's that missing side. So therefore, my area would be equal to 1/2 times 35 times 23.3 times, I nearly did an X for times there, the sine of the included angle, which is 82 degrees. Typing that entire thing into my calculator, I get somewhere around 403.8 square miles. And again, the more decimals that you do here, the more exact that's going to be. That might be off a decimal point or two. So you've got to be really careful. If you want this to be as exact as possible, I would string out and use 4 or 5 different decimal places there. So just a warning. This is definitely not a law of sines problem because you don't have any angles. A side is always going to be your law of cosines. So we do need to find any of the angles. We'll find this angle here. I know that a squared equals b squared plus c squared minus 2bc times the cosine of your angle A. So therefore, that'd be 23 squared equals the other two, 15 squared plus 21 squared minus 2 times 15 times 21 times the cosine of A. Again, we move the 15 squared and 21 squared over by subtracting. So you now would have 23 squared minus 15 squared minus 21 squared. You would move, now that you've got those gone, you would move these over, since those are being multiplied, you would divide by -2 times 15 times 21. That's supposed to be a times 21 right there. And that will equal the cosine of A. Once you get all this typed into your calculator, once again, you will do the inverse cosine of that to move the cosine over, and that would tell you the value of angle A. 77 point, and I'm going to put 3 decimals here just to make our answer a little bit more exact this time, about 77.440 degrees. So our area now, and again, this A doesn't stand for area, that's our angle. The area will equal to 1/2 times 21 times 15 times the cosine of the included angle, which is 77, or excuse me, the sine. I'm stuck on my law of cosines over here. My area formula is always sine. So the sine of 77.440 degrees. Typing that into our calculator gives us an area of approximately 153.7 millimeters squared. And number 10, the last one, I believe, will be identical to the problem that we just worked. We can find any of the 3 angle measures. doesn't matter which one. We'll find this measure right here, and again, you can call it a if you want to, but we're going to use law of cosines. So you have a squared equals b squared plus c squared minus 2 times 17 times 16.5 times the cosine of the angle that you are looking for. We move 17 squared and 16.5 squared over by subtracting. We will then divide by this stuff. We will take the inverse cosine, and we will find out that our angle is somewhere around 82.1 degrees. So therefore, we have the area of our triangle is equal to 1/2 times 17 times 16.5 times the sine of that 82.1. Again, to make it more exact, you can round that to a greater number of decimals, but we're going to have an area somewhere around 138.9, and that is in meters squared.